Welcome to Table Talks. So we are still empowering you with more questions related to solving questions. Our question 2 goes, solve the question, root of 5x minus 25 minus root of x minus 1 equals 2. So when the question comes in this way, it is under Sadiki equations. So what you're going to do, we can first take this one to their side. We are remaining with root of 5x minus 25 equals 2 plus the root of x minus 1. So what do? We are going to square on both sides. I can say squaring on both sides. Squaring on both sides. So we are having the root of 5x minus 25, the whole of it squared equals 2 plus root of x minus 1, the whole of it squared. Also, recall that the expansion of a plus b squared is the same as a squared plus 2ab plus b squared. So what we're going to do when we expand, the square crosses with the root, and I will remain with 5x minus 25 equals, this is like here we are getting 4 plus 2 times the 2, we are also getting a 4 root of x minus 1 plus the root of x minus 1, the whole of it squared. So can we go ahead and we try to expand? We are getting 5x minus 25 equals 4 plus 4 root of x minus 1 plus x minus 1. Again, we try to collect like terms in the right hand side. So we are having 5x minus 25 is the same as 4 minus 1, we are getting a 3 plus x, again plus 4 root of x minus 1. Again, we try to collect like terms. So we are having 5x and we bring this x here, we shall get 4x minus 28 equals 4 root of x minus 1. So can we see what is common is a 4. We divide out by 4. Can say dividing by 4. Dividing by 4 on both sides. So can we divide by 4 on both sides? We shall remain with x minus 7 equals root of x minus 1. How can we eliminate the root? We can say by squaring again on both sides. By squaring again on both sides. On both sides. So we are having x minus 7, the whole of it squared is the same as 4, is the same as root of x minus 1, the whole of it squared. Again, we expand using our binomial expansions, how we came out with this from what we did from here. So we are going to expand using this same identity. What is going to happen? We are going to have x squared minus 14x plus 49 equals, the opposite of a square root is a square. It implies that the square root is going to go with a square. So we are going to remain with x minus 1. Again, we collect like terms. We are having x squared minus 15x, then plus 49 plus 1, we are getting a 50 equals a 0. So this is a quadratic equation which is in the form of ax squared plus bx plus c equals a 0. So what we're going to do is this. we are going to look at the product, the sum, and at the same time at the factors. So when we try to look at our product is 15 and our sum is negative 15. We look at the factors. Can we think of two numbers? When you multiply them, we get 50, and when we happen to add, we are coming out with negative 15. So according to me, I'm seeing a negative 5 and a negative 10. When I add the two, I get negative 15. And when I happen to multiply, I come out with that. So what we are going to do, instead of this, we are going to bring these stuffs. So we are going to have x squared minus 5x minus 10x plus 50 equals 0. Tap, 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 tap. So what we're going to do, what is common here is still x into x minus 5. Again, what is common here is a negative 10 into x minus 5. The whole thing equals 0. So when you reach here, we are going to write x minus 10 again into x minus 5 equals 0. So we are going to say either x minus 10 equals 0, and when this one goes the other side, our x equals 10, or x minus 5 equals 0, so our x equals 5. So I've got two components of x. We need now to test for the convenient value of x. And I said when you are testing for the convenient value of x, we are substituting the original equation to see if it is bringing the exact answer, which is in the right hand side. So can we do the substituting for testing for convenience? So we are going to substitute in our equation. We can start testing for convenience, So we are going to start when x equals 10. When x equals 10, one substitute here, we are having root of 5 times 10, that is 50. 50 minus 25, we are getting 25 minus the root of 10 minus 1, we are getting the 9. 1 shift is bringing 2. The square root of 25 is 5. The square root of 9 is 3. So when you take, you get a 2. This implies that left hand side equals right hand side, which means the value of x is correct. We again also say when x equals 5, substituting, we are getting root of 5 times 5, we are getting 25 minus 25 minus root of 5 minus 1, we are getting a 4. 1 shift is bringing us a 2. 25 minus 25, we are getting a 0 minus the square root of that is 2. 0 minus a 2, you come out with negative 2. But the other side we have got a positive 2. It implies that left hand side is not equal to the right hand side. So how do you conclude the right value of x? You say therefore x equals 10. So out of the two values which we have come out with, we have seen that the correct value is the one which is 10. Because we have substituted and have seen the consistent value is that one. That's what you can do with that.